Okay, in problem number 22, we have what's called an orthogonal projection of 3 space onto the xy plane. And you take the point xyz and you map that back onto the point xy comma 0. Well, what does this mean? I doubt that this is ever something would be something that would show up on a test, but assuming that you had something in 3 space. So perhaps our xy coordinates. So xy plane is something that's lying flat on the page. The z axis would come out from the page to make it three-dimensional. And let's assume that you had any point that was anywhere in space, however many units away from the xy plane as the background there, either in front or behind it. It could be positive or negative z as well. So let's just say we have this point out here. Maybe it has the coordinates 1, x is 1, y is negative 1, and z is 4. Well, what this would do is it would basically have the point just go directly back, perpendicular back to the xy plane. And instead of coming out from the xy plane, it would just project back onto the xy plane. Anyway, this is not important. What it does is it's not a major thing. I don't think that you would ever be asked questions about an orthogonal projection of 3 space onto the xy plane without them telling you specifically what it is that they want you to do. And what they're saying is that this whole transformation can be represented by the matrix equation capital M, which is the name of a matrix, times xyz, a matrix xyz, is equal to the matrix xy0. So it would be the same exact x coordinate, y coordinate, but the z coordinate would now become 0. So it's lying on the xy plane. Well, what they're asking for, where M is which of the following matrices, and it's one of those matrices over on the right. A few things that you need to know about matrices and matrix multiplication. First of all, we talk about the dimensions of a matrix, and it's discussed in terms of its rows and its columns. Rows are always horizontal, and columns are always vertical. So each of these potential answers over here has 3 rows and 3 columns. However, in the matrix equation, the matrix XYZ that we saw has 3 rows and 1 column, as does the XY0 matrix. So one thing that you have to remember about multiplying matrices is that matrices have to match in a certain way. If the first matrix has so many rows, we call that R1, and so many columns, we call that C1, in order to multiply that times another matrix, the second matrix with so many rows and so many columns has to match the first matrix in the following way. The number of columns in the first matrix, or the matrix on the left, has to equal the number of rows in the matrix on the right. In other words, these two numbers have to be the same. And when those two numbers are the same and we multiply matrices together, we're going to get a resultant matrix that has the dimensions, the number of rows from the first matrix and the number of columns from the second matrix. So for example, if we had a 4 by 5 matrix, 4 rows, 5 columns, and we wanted to multiply that times another matrix, we could only multiply it times a matrix that had 5 rows in it. And let's just say, for the sake of argument, that it had 3 columns in it. Well, because the number of columns in the first and the number of rows in the second match, we can multiply these two together, and the resultant matrix would be a matrix with 4 rows and 3 columns. I hope that's clear. So if you notice that M is one of those matrices, is 3 by 3, has the same number of columns as does this matrix here, the XYZ matrix, which is 3 rows by 1, and when I multiply a 3 by 3 by a 3 by 1, the result will be 3 by 1, meaning that it has 3 rows and 1 column, which we can see here. So I'll continue this solution to this problem in the next video, and we'll talk about specifically how we multiply matrices together.